Today's lesson is on algebraic proof, but at a further maths level rather than a standard maths level. I'm going to do two examples with you, and then you are going to have a go at the worksheet I've put up. Please pause the video and have a go at these two examples, and then unpause it and see how I go through it. If you can't get very far with it on your own, that's fine, but at least pause it and have a little go. So this first example, show that 2x plus 5 over 3 plus 3x minus 1 over 2 simplifies to 13x plus 7 over 6. Hence, solve 2x plus 5 over 3 plus 3x minus 1 over 2 equals 8. So this is really a two-part question. The first part is showing that this sum simplifies to this, and the second part is solving this equation equals 8. Now this will often happen in further maths. A particular topic, so this is algebraic proof, will incorporate another topic. This is algebraic fractions. So I'm going to do part A first, show that this simplifies to this. If we look at the expression we are adding, and then we look at what we want to get to, the first thing we can see is the denominator here is 6, the denominators here are 3 and 2. So it's likely that we're just going to add these in the usual way for algebraic fractions. We are going to cross multiply or put them over the same denominator. So this is the expression that I have to simplify. So I'm going to multiply the top and bottom of this by 2. So I get 2 into 2x plus 5 over 2 times 3, which is 6. And then this one, I'm going to multiply top and bottom by 3. So plus 3 into 3x minus 1 over 3 times 2, which is 6. So these now have the same denominator, which means I can just add the numerators together. So I'm going to multiply this out, 4x plus 10 plus 9x minus 3 all over 6. And if I simplify that by collecting like terms, I will have 13x plus 7 over 6. So let's just compare that back with the question. That is exactly what we wanted to find. 2x plus 5 over 3 plus 3x minus 1 over 2. That's what I did here. Simplifies to 13x plus 7 over 6. 13x plus 7 over 6. Perfect. So that is the first part done. The second part says hence solve. If it says hence, they want you to use the first part of the question. So you are not going to now start this from the beginning again. You're going to use what you found in the first part of the question to help you with the second part. And if you look closely, and it is amazing how many times students miss this, this bit here is exactly the same as this bit here. And we know that this bit here turns into this bit. So if this equals 8, then this equals 8. And that is what they want you to use. So we're going to put this bit equal to this bit, and then that's what we're going to solve. So 13x plus 7 over 6 equals 8. And we've got 13x plus 7, multiply both sides by 6, which is 48. Then we've got 13x, subtract 7 from both sides is 41. And then 41 over 13, and I don't think that turns into anything, so we'll leave it as that, improper fraction. So we've finished that question. Now, where was algebraic proof actually in here? It was the show that part of the question. They wanted us to show that this turned into this and it's algebra. Bit of a tenuous link, you might think. I do too. But we've shown that this equals this. Really, we only had to use the skills we've learned in algebraic fractions. And then we had to hence solve this. We used what we've shown to make it easier. And again, it was just algebraic fractions. So quite nice and easy. Okay, the next example is a more straightforward prove question. So we've got prove that this expression is always positive. So proving, we're going to do it algebraically. We cannot do it by substituting in numbers. Now it says is always positive. What that means is we want to show that this is always bigger than 0. So that's what we're going to try to do. The way that we're going to show it's always greater than 0 is we're just going to start by simplifying this or expanding it out. Now, if you look at a question like this and you have no idea what to do, the first step is always just start expanding or just start playing around with the expression. Imagine that the words are missing. What would you do with this if you saw that and the words are missing? You'd probably just have a go at expanding it out. That's exactly what you should do here. So this is the expression that we've got, and we are going to expand it out. So 2x plus 3 all squared. It gives me 4x squared plus 12x plus 9. Then I'm going to expand this out, but in brackets because there's a negative sign there and students always get this wrong. 3x times x, 3x squared, 3x times 4 plus 12x, but in brackets because we actually need to subtract it. So multiplying that out, we've got 4x squared plus 12x plus 9 is already multiplied out. But here we're going to have minus 3x squared minus 12x. And we can see that the two 12x's are going to cancel. We've got a negative there and a positive there. So actually, this simplifies to 4x squared minus 3x squared is x squared and plus 9. Right, we cannot simplify that anymore. So let's see what we were supposed to be doing. We were supposed to be showing that it's always positive. So this expression that we have simplified is always positive. Can we say that from what we've found? We can. This is a very common trick that you will need to use. Anything squared is a square number, and square numbers are all positive, because you cannot have a negative square number. So this bit is positive, always. Then we've got plus 9. Well, clearly that is positive. So we can say x squared plus 9 greater than 0, since x squared is greater than 0 for all x. Well done if you remembered that you can write for all as an upside down capital A. So x squared plus 9 is greater than 0, since x squared is greater than 0 for all x, and 9 is greater than 0. Therefore, x squared plus 9 is greater than 0. Or x squared plus 9 is always positive, which is what the question wanted us to do. Okay, so that should help you with the worksheet I've put up. Now, the worksheet I've put up is quite tricky. It is further maths questions. They are a little bit unconventional, so have a really good go at them. I need to see what work you've done, so please submit it as an assignment on Show My Homework. But any questions that you get stuck on, and I do expect there will be a few, let me know and I will record a video on how to do the questions you get stuck on.